Hi, I'm Rohasad, and in this series of videos, we will be covering the syllabus of Cambridge O-Level Computer Science. In this video, we will try to develop an understanding of how and why a computer represents an image, including the effects of the resolution and color depth. So let's begin. First off, what is an image? You can see some squares of different colors. What happens if I add more of them? Let's see. Here I am adding more of them. More and more and more. I keep on adding more squares, and as you can see, it turned out to be a picture of a colorful flower. So basically, an image is a series of these tiny squares called pixels. The pixels in turn are made up of three colors: red, green, and blue. Conventionally, we restrict the shades of each of the individual colors to a total of 256 shades. This is equivalent to 2 power 8. So in order for us to encode an image into binary, we will use 8 bits to store the value of shade for each of the colors. The resultant color will be stored in 24 bits. We call it 24-bit color. This quantity has a special name, color depth, or the number of bits per pixel. Now we will look at the effect of color depth on an image quality. Suppose an image has a color depth of 16 bits. We reduce the color depth to 8 bits. As you can see that the image has lost some of its colors. It is not as vivid as the 16-bit image. This effect will be more pronounced if we reduce the color depth to 4 bits. You can see now there are not many colors. With 3 bits, only 8 colors are available. As color depth is reduced even more, the color range gets even more limited. We can conclude that with the decreasing color depth, the image quality declines. So there is a direct relationship between image quality and color depth. Now, what about the effect of color depth on the file size? Suppose you have 600 by 800 pixel image, or an image with 480,000 pixels. The color depth is 8-bit and 24-bit. For 8-bit, the image size is 480,000 times 8-bit, which is equal to 0.458 megabyte. For 24-bit, the image size is 480,000 times 24-bit. This equals to 1.37 megabyte. So the file size has increased 3 times. This shows that there is again a direct relationship between color depth and file size. Now let's consider image resolution. It is the number of pixels in an image. What is the effect of image resolution on image quality? The image shows letter A becoming more pronounced and clear as more pixels are added to the image. In the first image, there are only 10 pixels per inch, so the letter A is edgy. As more pixels are added, as in 100 pixels per inch, the letter A becomes more pronounced. So the image quality is improving with image resolution. What about the effect of image resolution on file size? If you think about it, the file size should increase with increasing resolution as more pixels or more details are being added. Let's look at the calculations. Suppose the color depth is fixed to 24-bit color. Number of pixels are 100, so the image size is 2400 bits or 0.29 kilobyte. We repeat the same calculation for this other picture. The number of pixels are 10,000. The image size is then 29 kilobyte. So there is an 100 times increase in the file size. A quick review of what we have covered so far. If you zoom in into an image, you will find small squares. Each square is a pixel. In order to digitize the image, each pixel is assigned a number, which is then converted into binary and stored in a computer. Color depth determines the number of bits to be used for each pixel. The color depth increases, image quality increases, and so does the file size. Image resolution is the number of pixels in an image. If image resolution is increased, the image quality improves and the file size increases. Now test yourself. Answer key will be displayed once you play the video again. This is the answer key. See you in the next video.